Hi everyone, in this short video I will show you how to simplify the block diagram model of the typical DC motor. So this is the block diagram model of the DC motor, in which we have two main parts. There's the electrical subsystem and there's the mechanical subsystem. And we have two kind of inputs. The first input is the control voltage, which is used to determine the speed of the motor, and the second one is the torque disturbance, which is not in our control. And we can see here that there is a internal intrinsic feedback inside the motor itself, which feeds back the speed of the motor with the gain of k. Now our aim is to simplify the model of the motor and find out this kind of model, this kind of block diagram indeed. So we want to have U as the input to the motor, and we would like to have the disturbance as an additive term to the output. So here we will have C, which is our speed, and here we will have the disturbance dH, where I call this transfer function HP. So now what we need to do is to find out G and HP transfer functions. Afterwards, we will be able to use this model, and later on we can design the controller in order to control the speed of the motor, for example. So let's see how we can do it. So by looking at here, as the first step, I would say that we need to move this block, which is the mechanical subsystem, from here to the right side of the summing point. So how can we do it? If you remember from the rules that we have for movement of the blocks to the left or right side of the summation point, we will have this kind of situation. So I will redraw the block diagram here. Here we have K over R plus SL. Then if I move this block 1 over B plus Sj, it will appear here 1 over B plus Sj. Then here we have the summing point with a positive sign both. Here we have the edge, and if I call this C, we will have this feedback gain of K, and then here we have the negative feedback. So what remains here is to determine the transfer function here. Having a look here, we see that dH is multiplied by this transfer function and appears in the output. So we will have 1 over d plus sj here as well. So here now the next step is that we can combine these two with each other because they are in series with each other, and the resulting transfer function is the multiplication of those two. I will draw it here. So what we have is K over R plus SL times D plus SJ Then we have the disturbance affecting the system with this transfer function b plus sj, output c, and feedback gain of k. So this is what we get. These are plus signs. But if you compare this function block that we have here, function block configuration, with what we would like to obtain, which is this one, you can see that they are not the same as each other, yeah? Because we want to have the effect of the disturbance to appear as an additive term as at the output. But here, that is not the case. Here, we are feeding back the effect of the effect of the disturbance through this path. So how can we simplify it? One way is to use the superposition theorem. Here we are dealing with an LTI system in which we have two inputs. The one input is U here, and the other input is DH. So how can we simplify it? We can take into account two cases. For the first case, we assume that DH is equal to 0 all the time, and then from here we will have this block diagram situation. So we have k over r plus sl times b plus sj. We have summing point here, but since the input to this summing point is 0, it will not have any effect on the output. So we can simply neglect it. Plus minus, and see here. So this will not have any effect. As a result, our block diagram system will look like this. Plus minus u, here we have k, k over r plus sl times b plus sj, and negative feedback. So this is the usual feedback configuration, and we know that c over u now is given by k over k over r plus sl times b plus sj divided by 1 plus k times k over r plus sl times b plus sj. And if you simplify it, we will get c over u given by k over r plus sl times b plus sj plus k squared. So this is one result that we have. Indeed, this is the transfer function from u to c. Now we need to find out the transfer function from dh to c. Indeed, we need to find out cs over dh of s. So to do that, we will assume that u is equal to 0 because we are going to use the superposition theorem. So if we assume this, we will end up with the, so this is our main block diagram system. Here, if we assume that we have u equal to 0, then k, this gain here, back gain, will be in series with this transfer function here. So these two will be multiplied with each other. And as a result, we will have this new configuration. So this will be our output. C, summing point here, with positive sign. This comes from the edge in which we have the transfer function equal to 1 over b plus sj. This is the transfer function k over r plus sl times b plus sj. And from here we have k with a negative sign. Or we can just transfer the negative sign to the other side. However, from here, we can redraw it in this way. So here we have the edge 1 over b plus sj, summing point with positive sign. The result is c, the output of the summation point, and here we have the transfer function of k squared over r plus sl times b plus sj, and the sign of the feedback is negative. We can simplify it further, especially this part. This feedback part could be simplified. We have the forward pass with the transfer function equal to 1, and the feedback transfer function is this guy here. So as a result, let me redraw it here. We will have this situation: the edge 1 over b plus sj, and then here we will have the new transfer function which gives us c. And I will call this maybe g1. So we can calculate g1 now. G1 is given by, so if you have a look here, it will be 1 over 1 plus transfer function in the feedback, k2 over r plus sl times b plus sj times the transfer function in the feed forward pass, which is 1. And from here, we can find out that g1 is equal to this r plus sl times b plus sj will appear in the numerator, and in the denominator we will have r plus sl times b plus sj plus k squared. This is our g1, and the overall transfer function from dh to c is given by this transfer function times g1. So we will have c over dh is given by, the first transfer function is 1 over b plus sj, 1 over b plus sj times g1. And g1 is this guy here, r plus sl, b plus sj over r plus sl times b plus sj plus k squared. And here we can see that b plus sj appears both in the numerator and the denominator. And accordingly, after simplification, c over d is given by R plus SL over R plus SL times B plus Sj plus K squared. And we call this HP. Okay, so now we can see that we have found the transfer functions that we would like to have, G of S and HP, in which I write it again here. So for this configuration, we have G of S coming from here. So K over R plus SL times B plus Sj plus K squared. I just write it again here. K over R plus SL times B plus Sj plus K squared. And HP of this is given by this transfer function here. So it's R plus SL over the same denominator. So it's R plus SL over R plus SL times B plus Sj plus K squared. So this is the simplified block diagram model for our DC motor. Later on, we can use this model in order to design the controllers, different kind of controllers for the system. All right, that's all for this video. I hope you have enjoyed it and you have learned something in terms of simplifying the block diagram systems. Thank you for watching and see you next.